So this is what I have. I'm not sure if I'm
Okay.
doing it right.
Yep, you're doing it fine. So now all you're going to do is subtract your volume,
My volume.
I'm
So
going to write on your screen. Hold on. Give me a second. I'm working, so just save your question and I'll answer in a second, okay? Keep on, it'll come. It'll start working. It's just because the yeast is old. Okay, so you're going to subtract this value from this guy. Okay, because then that's going to give you your estimate volume. So the hydrogen peroxide that you guys are using is about 3% hydrogen peroxide and then 97% water. So the water isn't going to be really involved in the reaction. We're just concerned about that hydrogen peroxide. So if you think about this being 60 mils, right? If the majority of it's water, its density is going to be exactly the same as water, pretty much. Okay, because we have 3% hydrogen peroxide. And 97% water. Okay, so if 97% is water, only 3% is hydrogen peroxide, we can sit there and use the density. Density of water is 1 milliliter per gram. And so that means that 60 mils is going to be the same thing as about 60 grams of solution. So, and we know that 3% of that, so 0.03 is hydrogen peroxide. So we have 1.8 grams. Okay.
Yeah.
Okay. So this here is going to give us our final volume, or the volume of just of the gas, right? Okay, so then that's what that is, and it's in liters. So you're going to use that in this equation right here. Okay, you know that this here is equal to R. This guy is equal to your T, and your P is going to equal 1 atmosphere. Oops. So you need to put that on your table as well too.
The P?
Yep. Okay. But you want to put like one by itself, just put the unit, say, put pressure, P for pressure, or pressure, P, and then kind of like you did, yeah. And then put 1 atmosphere underneath it, just 1. And then on the line of pressure, you just tell me the units, atmosphere. So then that way you can
like
use
that?
it. Yeah, that's fine.
Okay. So the final volume is not 500 then?
No, the final volume, so you're assuming that you maxed out, right? And so in other words, we went above what we can actually calculate. So we're just going to calculate the maximum we can calculate, which is 500. But you also know that you started out with 60, but 60, see? You had 64 milliliters of solution that was added to that volume. So at the bottom, you have that water that's still there, and everything else that's reacting is making the gas, and that was able to exceed the 500 mils, right, of the bottle.
Oh, so you're saying I kind of get what you're saying. So you're saying the 64, you don't really count that, so you will subtract 500.
That's right.
over the
We don't want to
65.
count that. Exactly. Yeah. Okay.
Oh,
So
okay.
this here is in milliliters. The 436. I keep forgetting you can't see what I'm writing. So this guy is in milliliters, right? We need to change that to liters, and we change that to liters by dividing it by 1,000.
Oh, well.
Yeah,
Oh,
because you remove this value here. You want to put your 500 there. You took that out.
And then you divide it by 1,000, you said?
Yep. But no, you want to put it in put the first part in parentheses. So yeah. Okay. Okay, so then that's going to give us our volume. You don't need to drag it down, because all you're going to need is a single one. You don't need all of these. Okay, you're just collecting all that data for later on, like to make sure that you account it for everything that you added to your solution. That's all you're collecting that for. Okay.
Oh,
so now you're going to use this equation here, right? Plus this is your volume. This is your V. Right?
I don't know what you're writing.
Can you see that?
Oh, yeah, that's all I mean.
You're going to use this equation down here.
So PV,
to solve
we
for
know
n.
P is 1.
That's right.
So it'll be 1.
Yeah, but
then,
okay, wait, slow down. So move this over. This guy here is your theoretical. Move your theoretical over 1. Move your percent yield over 1 more. And then here you're going to put actual yield.
oh, I messed that up.
Yep, don't worry, but you can retype it in later.
Yeah, actual.
Okay, so actual yield is going to be there. And you want to put it in moles. So put parentheses, mole.
Mole.
Okay, so now you're going to use this equation. You're going to plug all of these numbers into your equation, into this equation down here. Well, you're going to type in that equation, right? So it's going to be your P times your V divided by, or parentheses, your R and your T. Where's your P?
Right here, the 1.
Okay, so then you go put equal sign first.
Oh, equal sign.
Okay, and then
14.
click that one. Click it, and then hit star.
Star.
And then here's your V. So star C, yeah, click that one. And then divided sign. Yeah, divide it. Yep. And then parenthesis. Other way, not close parenthesis. So go ahead. Yeah, open parenthesis. Yeah, that'll be fine. R times star T. There you go. And hit return. Okay, so then that's your actual yield. Okay, so now that you calculated your actual yield, now you need to calculate your theoretical yield. So you're going to start off with 1.8. So, okay, how do I change grams into moles? 1.8 grams of hydrogen peroxide.
Okay. So what do you put, like something right here and then moles up top?
Okay, so then how do I calculate what I put down here?
That's why I get confused, to be honest.
Okay, well, think about it. What do we know? We know the chemicals. So what can I use to calculate the mass of the chemicals?
We could use.
what is it called? That table thing that has all of the chemicals and how much the chemicals weigh on it?
Atomic mass? No.
Yes, the atomic mass. So what is the atomic mass of hydrogen?
I don't know. Do I look it up?
Okay, go ahead to P table.
Oh yeah, P table is easy. Table. One point.
Okay.
Oh wait.
So we're just going to estimate it's going to be 1. So, and we have how many? How many hydrogens do we have in hydrogen peroxide?
2.
That's right. Okay. So 2 times 1.
2 times 1, 2.
Okay. And then oxygen, how many oxygens do we have?
We have 2.
Okay. So, and then how much does oxygen weigh?
Oxygen. $14.999, so 16.
16. Okay. So 16 times 2.
36.
Okay, and then we add them together.
Oh, 32. 34.
Okay. So this guy's going to be 34. Grams per 1 mole. Okay. And then that is of hydrogen peroxide.
So the bottom one and to the left one, this one's gonna cross out, right?
Yep.
And then we're gonna be left with this, and then we have to calculate with the calculators.
Yep. But there's still a little bit more before we get to that. Okay, so we know what the equation was. Hydrogen peroxide is being decomposed to what?
To
You should have been paying attention when they were sitting there talking about this.
I was too busy doing the lab.
I know, but you could do 2 things at once. I've seen you play video games and try to listen to my lecture at once.
It's possible, but it's hard.
Hey, Dr. Henry, sorry to interrupt, but this is like, we use the same equation from our last lab to this one, right?
Yep.
Oh, okay.
Yep. Okay, so hydrogen peroxide is going to be broken down to what? One of them is a gas. It's a gas that we need to breathe. That's my hint.
Oxygen.
Okay, so we know that we have oxygen. Oxygen gas looks like what? What is the chemical formula for oxygen gas?
O2.
Okay.
Because of the it's because of the one thing that you were talking about, something with the
Have no fear of ice cold beer.
Yeah.
Yep. Diatomic, yes, because it's diatomic. And then the other thing is going to be water, right? Okay, so those are going to be our 2 products. Okay, water is the liquid, oxygen is the gas. The gas is what's kind of making the foam. Okay, so is it balanced?
Is it balanced? No.
Okay, so we need to balance the chemical equation. How can I do that?
So you would, let me write down a piece of paper. Let me do it real quick.
Okay.
H2O, 2, 25, O2. Oh. So these 2 are together, right? So we can't like put like a 2 here.
Together, you can't do that.
So 3. I got it, I think.
Okay.
Two. You would put a 2 in the right here in the O2.
Are you sure?
Oh, I'm still not finished. I was just
Okay.
doing it real quick. Two.
I always like doing it simple. I like to write them down so that I can see what I'm doing. So I'm a visual person. H, and I'm going to erase this down here.
I mean, I'm doing the same process. I'm just trying to figure it out. So you will put 2 right here. I'll make it 4. I'll make this 4. How about you put a 2 in the H2O in this side, and then put another 2 in this side?
Okay, that looks good. Okay, so then that'll be 4
and 4.
and 4, and then 4 and 4. Okay. Okay, so then now you have a balanced chemical equation. Okay, so for every 2 moles of hydrogen peroxide, how many moles of oxygen can you make?
2? No, 4. 4 now.
For every 2 moles of hydrogen peroxide, how many moles of oxygen gas can I make? Look on the other side of the equation. If I have 2 moles of this guy, how many of these can I make?
What are you pointing at? I see a lot. Oh.
So if for every 2 moles, okay, Alex, let's do it like this. Okay, because you're overthinking it. So 2 pieces of bread plus 1 cheese is going to make a cheese sandwich. So Alex, if I have a piece of bread, if I have 2 pieces of bread, how many cheese sandwiches can I make?
1.
1. Okay, Alex, if I have 2 hydrogen peroxides, how many oxygens can I make?
1.
Okay, so it's a 2-to-1 ratio. So you're using it to compare the two, right? It's like a recipe. It's the same type of recipe that you're doing with your cheese sandwich. So you're just using it as a recipe. So if I have 2 hydrogen peroxide, I can make 1 oxygen and I can make 2 waters. So I can use that. So it's for every 2 moles of hydrogen peroxide, I can make 1 mole of oxygen gas. Okay,
Yeah.
so then that'll let me know how many oxygens I can make in theory with this amount of hydrogen peroxide. Okay, so then you would go ahead and multiply it across and divide by these numbers here. And what do you get?
Let me get my calculator out.
Okay.
Where's it at? So the turn it on. 1.8 divided by 34, and then divided by 2, right?
That's right.
It's going to be 0.0265 if you want to round it.
0. Okay. So then we're going to use that value for, that is going to be your theoretical value.
Okay. Okay.
And that's moles of oxygen. So that's what you're going to put in that value right there.
Would you put the points though?
Yeah,
Point
you still put the point.
265.
I just make my circle a little too small. Okay. So then your percent yield, it's going to be your actual over your theoretical.
You be theoretical.
No, it's going to be your actual.
Oh,
Actual over your theoretical.
actual divided by
Yep.
theoretical.
And then you need to multiply it by 100. So put that in parentheses and multiply that by 100.
Yeah. Oh, what the hell did I do? I think it was E2, right? Times 1,000?
100%.
100.
Yeah. Okay.
Okay.
And so that would be your percent yield.
So we don't have to drag it, huh? It's just
Nope.
like that?
Nope. There's only a single value.
I just making sure because we usually just drag it.
Yeah, but that's if you had a lot of data points. You don't have a lot of data points. There's only one point. That was it.
Oh, all right.
You did only one experiment. That was it.
So we would have done multiple. We would have put it over here, like a little bit more information. Like say that if we did another one, we'll probably do like 0.47 or something.
Yep.
And you would have done this too.
Yeah. Yep.
All right.
Okay.
Okay.
Piece of cake.
Not a piece of cake, but I kind of got the hang of it.
Okay. Take a picture of the map because you're going to need to know it. Okay.
Okay.
Aaron.
Is this all for the lab?
Yeah, that's it for the lab. And then there's a couple of questions. Answer the question.
Okay. Sounds
Okay.
good.
Okay.
you so
Aaron,
much.
Yes.
are you good?
Yeah.
Okay. And Alina?
Yeah, I was gonna ask you a question on like the lab because I got confused on like I understand the part of theoretical and calculating it, but I wasn't sure the first part of the 60 millimeters, like finding what to multiply the first mole of it, I guess you could say.
Calculate the moles from the volume. Is that what you're asking?
Not calculated, but like I have the whole equation out, like the 1 mole and like the amount of grams of hydrogen peroxide is.
Yeah.
But it's just the beginning, like to find the gram of the millimeters. That's the only part I got lost in.
Okay. So let me go to a whiteboard. Okay. So you put 60 mils of hydrogen peroxide. Let me clarify. So if you look on your bottle, it's 60 mils of 3% hydrogen peroxide. Okay, so that means 3% of it is hydrogen peroxide, 97% of it is water.
Okay.
Okay, so we can pretty much say that the majority of it is water, right?
Right.
So then we're going to make an assumption. So we're going to assume that the hydrogen peroxide isn't going to affect the density of water too much. So the density of water is going to be 1 gram per mole. I mean, milliliter, sorry. Talking about moles all day, so. And so this is the density of water. Okay, so if the density of water is 1 gram per
Okay.
milliliter, how many grams would this guy be? Milliliters are going to cancel out, and we're left with 60 grams. So altogether, that 3%
Okay.
is going to be 60 grams. Okay, now we know that 97% of that is water. The other 3% of it is hydrogen peroxide. So if I multiply this, is 60 grams by 0.03, that would give me how much of it is hydrogen peroxide. Okay, so that's how much is hydrogen peroxide, and then that means that the rest of it would technically be water, right?
Right. Okay. Now I get it because I saw the example because I came in late when you were doing the example for Alex and I was reading it but I wasn't sure. I was right in my head like, okay, maybe that's how I actually did it, but I just wanted to verify it.
Yeah, no problem.
Okay.
Yep.
Okay. Thank you. Thank you,
No
Dr.
problem.
Henry.
Yeah, no problem. Okay, are you guys good?
Yeah, I have a question. So
Okay.
I asked not the people in my group, just before we split into groups, if what was due today was due today or if it was going to be pushed. Because I know that the homework is due at 11 tonight, and then the lab tonight is, or the lab write-up is due. Is that going to be pushed, or will it be due both tonight?
Everything is going to be pushed till the 21st. So your lab is going to be, everything can be turned in by May 21st. Does that help?
Yeah. All right. Thank you.